So we're in lesson 5.8 on the homework assignment in the textbook, 1 through 10, 13 through 16. So on number 1, we are looking at this archery target. We've got a square, which if we want to find the area, base times height, length times width. And we have a circle, which area is pi r squared. We need to know those formulas. So letter A, what's the area of the bullseye? So that's a circle. So area equals pi times radius squared. So area equals pi times, this is the radius. If they gave us the distance all the way across, we would need half. Radius goes from the center to the outside. So it is 0.7, and that has to be squared. So we're going to do 0.7 times 0.7, which comes out to 0.49. And we're going to leave pi. We're not going to go ahead and multiply it through. For all of these, there's lots of situations where pi is going to end up canceling because you're going to divide two things that have pi in it. Sometimes it won't cancel out, sometimes it will. But for the sake of not having some long decimal that we either need to round or write all the way out, we're just going to leave pi alone. So when we do keep pi in an answer, it kind of sits like an x. It's going to have a coefficient. We normally write the number out front. So when we get 0.7 squared, that's 0.49. So we're going to go ahead and put it, our final answer, as 0.49 pi. Part B, what's the area of the entire board? So area is just base times height, which in this case is the same number, 2.3 times 2.3. And when we multiply those together, we get 5.29. Now part C, to the nearest percent, what's the probability that an arrow shot at random hits the board and will land in the bullseye? So we're comparing our favorable outcome, which is here. Compare that or divide it by to find a percentage, the total number of outcomes. So the total outcomes is anything on this board, which is represented by the area of the square. And the favorable outcome in this case, since we're trying to hit the bullseye, is the whole area of the circle. So if we're going to compare those two, we're going to compare 0.49 pi to 5.29. So this is your favorable outcomes to your total outcomes. And we're going to go ahead and divide that. So if you're looking for your pi button on one of these calculators, you will find it right here. So it's in blue. We got to hit second and then the little up arrow or the raised to. And we're going to divide that by 5.29. If you don't include the pi in there, you're not going to get the right answer. Remember, pi is a number. So this is actually saying 0.49 times pi. So if you just leave out pi, you're missing multiplication that needs to happen. So you will not get the right answer without pi in there. Divide. And it says to the nearest percent. So this would be 29%, and the 0 after it means we're not rounding it at all. And so we're going to go with just 29%. Part D. What's the probability that the arrow hits the board and will land on the target outside the bullseye? So what's the probability that it hits out here? So the long way to do this, if we didn't already have this percentage right here, would be to find the area of the blue region out here, which would be the area of the square minus the area of the circle. If you take away this from the whole thing, you're left with the blue area. And then you could compare that to the whole thing like we just did, and that will get you the correct percentage. But since we already know it's a 29% chance of hitting in here, the entire board represents 100%. So if we're taking 29% out of that, we have 100% with the board. If we're talking about hitting the part outside of our 29%, that leaves us with 71% of the board. So again, we could have gone through the process of finding the area of this shaded region or the blue region and then dividing it by the total. But in this case, there's a much easier way to do it. So we're just going to go with that, 71%. Okay, number 2, we're drawing 3 different spinners that have a 2/3 probability of landing in a blue region. Easiest and fastest way to do this for your first one is to just split it in nice 3 pieces. We'll call this blue, we'll call this blue, and we'll call this green. This is 2/3. Another way, if we set it up pretty much the same, but then we cut each one of these in another piece, but we count the same amount, so blue, 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 so we filled in the same amount as this, then they should be equal. And so this is 4 out of 6, which is also 2/3. And then you just have to come up with some other way. So you don't have to necessarily split it up evenly. You could do this. And here's half. And that's kind of like 3/6, because if I cut this whole thing out, it's kind of like this piece right here. And I just need one more. So I have a half, and then I have a third of a half. But altogether, that's, again, 4/6 and 2/3. So they just want you to see that it represents, even if it's cut into different pieces, in terms of how many pieces, it can still be represented as a 2/3 probability. As long as 2/3 of the board is blue, even if those 2/3 are cut up differently, it's still the same amount. All right, number 3. So you have a clock. The second hand is stopped by a power failure. What's the probability that the second hand stopped between the following two numbers? So first of all, we need to start thinking about what this is going to look like. So here's our clock. And we got 12 o'clock up here, 6 o'clock here, 3 o'clock, 9 o'clock. And this is going to be split with 1, 2, 4, 5, 7, 8, 10, and 11. And think about this like a spinner. They want to know what's the chances that this second hand, when the power stopped, is between 12 and 2. So how many different regions do we have here? So if I give this circle a center, and I just draw a line to every single number, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different regions. So what's the chances that it stops between 12 and 2? So somewhere between here and here. So out of this whole thing, out of 12 regions, think of it like a pizza, 12 slices, between 12 and 2 would be 2 of them. So again, it's out of 12, we're talking probability. It's a 2 out of 12 chance that it's in there, which simplifies down to 1/6. Part B, what about between 5 and 6? So between 5 and 6 is just one of these. So that's 1 out of 12. And part C, between 7 and 11. So we've got 1, 2, 3, 4. So 4 out of the 12 regions are between 7 and 11. And so 4 out of 12 can simplify down, divide by 4, and that is 1/3. Okay, number 4 and 5 are going to be the same idea, except instead of circles, we're looking at a straight line with distance, but it's still talking about the piece compared to the total. We're talking about the piece, the shaded region, compared to the total. So a student from the University of Chicago is going to ride her bike to Loyola University. Along the bike track, she's going to make stops at Navy Pier and North Avenue Beach. The student gets a flat tire on the trip, and there's an even possibility of getting it anywhere. What's the probability it occurs in certain locations? So there's a lot greater chance that it's going to happen from here to here because there's just more time that she's going to be riding, more distance that has to be covered. The least amount of probability would be in here, and then this is your middle probability. But we're going to find out the exact percentage if there's no other factors, of course. Now, you could say, well, over here, there's a lot more potholes than over here. Of course, you could get into semantics like that. But if we're just talking about miles, what's the probability? There's more miles here. That's a higher likelihood that it's going to happen in here than it is inside the 2.24. So let's find out the exact amount. So first of all, whenever you're going to do probability, it's the favorable outcomes to the total outcomes. So if you're just talking total outcomes, we need to know what's the distance of the whole trip. So they didn't give us that information directly. We're going to need to add up all these pieces. So 19.12 is the total distance. And for number 4, they want to know what's the chance that it happens between Navy Pier and North Avenue Beach. So that's that small little stretch of 2.24. So we're going to compare that to the entire trip. 2.24 miles between Navy Pier and North Avenue Beach is how much of the trip, what percentage of the trip, and that's also the probability, percentage probability that it happens in that span. So 2.24 divided by 19.12 looks like this. Again, this is a percentage, so you're going to move that 2 spots. So 11.7, the 1 will keep it the same. So we're rounding it approximately 11.7%. Number 5, what's the chance it happens between the University of Chicago and North Avenue Beach? So somewhere in this span. So that includes the 9.32 and the 2.24. Now again, we're comparing it overall to the entire trip. What percentage of the trip is between University of Chicago and North Avenue Beach? That's the same as the probability. So comparing it to the whole trip, we're going to use this again. Now we have to add these together. So we need 9.32 plus 2.24. That portion of the trip is 11.56 miles. So if the whole trip is about 19 miles, what percentage of the trip is here, which is also going to correspond to what's the probability of a flat tire happening in here. So 11.56 divided by 19.12. Move it 2 spots. 60.4. The 6 will kind of bump that up. So we'll say approximately 60.5%. All right, let's start on a fresh page for 6, 7, and 8 because we're going to need some space here for our area. So before we get to 6, 7, and 8, we're going to need to find the area of all of these circles. So let's start with the small circle that has a radius of 3. Area equals pi r squared, so area equals pi times 3 squared, so area equals 3 squared is 9 pi, and we're just going to leave 9 there. Now let's look at the medium circle, which has a radius of 6. So be careful. A lot of times students will just throw a 3 in there again, but clearly the circle's bigger. It's the 3 from the yellow plus the 3 out here for a total of 6. If you're looking at the circle that's outlined around the red. So that circle has a radius of 6. So area equals pi times 6 squared. So it's 36 pi. And the biggest circle has a radius of 369. So area equals pi times 9 squared. So that's 81 pi. Now, just looking ahead, we're going to find the bullseye. We're going to look at the outermost ring, so not the full circle. And we're going to look at the middle ring. So right now, some people will want to use the 36 pi as this ring. But that's not the ring. That's the whole circle, including the bullseye. So if we want to take out the bullseye and just leave the ring, that's subtraction. So I'm going to go ahead and do that right now before we get there. If I just want the red ring, what I need is the area of the whole circle, which is 36 pi. And I need to cut out or subtract the yellow because that's not part of this area. So I need to take out 9 pi. So that's going to equal 27 pi. So the red ring is 27 pi. And then what about the purple ring? The purple ring, you can't take 81 pi. 81 pi is the entire circle. So since this one is 27 pi, in here, the red ring, and this is 9 pi, you could take them out one at a time. But what's even better than that is we know that this whole circle inside of the red, including the yellow, is 36 pi. We also know that the entire circle, including all of it, is 81 pi. So if we take 81 pi, the area of all of it, and we cut out the ring and the circle, which is going to be this whole middle area with a radius of 6 of 36 pi. What we're left over with will be this outermost ring. We've cut out all of the middle, which is equal to 36 pi, and we are left with 81 minus 36, 45 pi. So we did all that work so we can go ahead and figure out our percentages. Probability is out of the total, so our total is going to be 81 pi. So everything is going to be compared to 81 pi because that's the coverage or the area of the entire dartboard. Okay, so number 6, what's the probability that lies just inside the bullseye? So we're going to compare the area of the bullseye to the area of the whole thing. So that's our favorable outcome. And then our total outcomes is anywhere on the board. So number 6, we are comparing the bullseye. What's the chance I get it in the bullseye, which is 9 pi, compared to the whole thing, which is 81 pi. So we can go ahead and solve this out. We don't need to plug it all in the calculator. Pi's are going to cancel each other out. And so we have 9 over 81, which simplifies, divide by 9, and you get 1 over 9. So you have a 1 out of 9 chance. And you could turn it to a percentage as well if you wanted to divide 1 by 9. Okay, number 7, what's the probability that it lies in the outermost ring? So this ring out here, we've already done the work, is 45 pi. So the chances it goes in is 45 pi out of 81 pi. We can simplify, knock out the pi's, which is why we leave them in the first place. If you made these decimals, now you've got to deal with all that. So we leave the pi's alone. They're going to cancel each other out here. And so we have 45 over 81, which will simplify down to 5 over 9. So you have a 5 out of 9 chance. And number 8, what's the probability it lies in the middle ring, which is the red ring, which is 27 pi. And again, the probability is that compared to all of the possibilities, which is 81 pi again. Pi's cancel. You could divide these by 9, and you're going to get 3 over 9, which again simplifies one more time. Divide by 3, and you get 1 out of 3. And your calculator will do that all for you in one shot if you plug in 27 over 81 and your fraction. Okay, number 9. The land area on Earth is this many square miles, and the water surface is this many square miles. Give the probability that a meteor hitting on the surface will fall on land and fall on water. So we have the land and the water. When we're talking about probability, we're comparing one of those to the total landmass or the total square miles. So when I go ahead and set up a probability here for either one of these, my A or my B, for both of these, I'm comparing it to the total. So I don't have a total right now. I have the land and I have the water. So if I want a total, I'm going to have to add these together. So 57, 510 plus we get this big number. That is our total if you add it all together. Okay, I'm going to go ahead and put that down here too while I'm at it. And now for each one, I'm just comparing the land to the total and the water to the total. So what's the probability that the meteor will hit land? So the land area is 57, 510 compared to the total amount here. I'm going to go ahead and divide. A little tedious just punching in all the numbers. We divide, and this is our percent, so we move that 2 spots, 29.2, 0 keeps it the same. So we're going to say about, because we did round it, 29.2%. And then for the water, we're going to take the square miles of water and compare it to the total amount of square miles and divide. And we move that 2 spots. 70.7, but the 9 is going to bump it up, so about 70.8%. Now thinking back, since there's only 2 options, there's not a third option. There's either land or water. Once we know that there's 29.2% land, the rest of the 100% is going to have to be water. So we could have just subtracted this from 100% and we would have got this. So either way, these two together have to equal 100%. So these are complements. Okay, number 10. You have a rectangular yard. So remember, that's just base times height if you want to find the area. And they kind of just spell out what you can already see in the picture. A newspaper is thrown randomly. What's the probability it lands at a point in the garden? So we're comparing the garden to the whole yard. If it was exactly half the yard, it would be a 50% chance because it takes up half. So we need to figure out how much it's taking up. Now, we don't have actual numbers, but if we did, this area, which is what we're going to put on top, is going to be compared to the whole thing, which you get from multiplying these two. So again, your total possibilities is the total area of the lawn, which would come from P times Q, whatever those happen to be. And what we're talking about is what's the probability it lands in the garden. So we need the area of the garden, which you would multiply these two numbers together, which is A times B. And that's it. On to number 13. Similar question. We do have a circle again here. What's the probability that a point selected from this region within the red rectangle, so inside the red rectangle, is also inside the circle? So basically they're asking what's the chance of getting something inside the circle, but only looking at the red region. So we've got this little bit of extra graph out here that's in white. That is not included. So we don't have to find out our total area out to the end of the graph. We are just looking at inside the red rectangular region. So going along with everything we've been doing, you need to find the total area of the rectangle, and then we're going to find the probability that it hits inside this circle. So we're going to compare the area of the circle to the area of the whole thing. So we can start with either one. Let's start with the rectangle. It's going to be just base times height. And when we read this, we need to just be careful. A lot of times students will mess this up just with counting boxes. So they get confused on how to count the boxes. So first of all, notice where the red ends. It's between -6 and -4. So this is -5. So from here to 0 is 5. And then it goes out to +5 over here. So all the way across, this is 10. And from top to bottom, we're going from 8 to 8. So from 8 to 0 is 8. And then it goes another 8 out. So that's 16. So when the area of the entire region, so not just the red, but if this was totally filled in, all of this rectangle, so including the circle, all of this is 10 times 16. So that's 160. And then with our circle, we're going to need a radius because area is pi times radius squared. So radius is just from the center to the outside. So you can see the outside of this circle is right between 2 and 4, so it's at 3. So the radius is 3. So pi times 3 squared. 3 squared is 9, so our area is 9 pi. So now we have everything we need. Find the probability that a point selected from this region is also inside the circle. So we're comparing the area of the circle to the area of the whole thing. And there's nothing to simplify here. There's no pi to cancel. 9 and 160 isn't going to simplify. Okay, there's nothing that goes into those. So we're going to go ahead and just leave it like this. If you really wanted to, you could plug it in and divide and get the percentage. Perfectly fine to express it that way. This is the answer you'll see in the book, though. Again, there's no rhyme or reason. Sometimes they give it as a percent, sometimes they don't. So as long as you understand that this is also equal to a percent, and you can jump between the two, you're fine. On a test or a quiz, which is always the concern, I'll be very specific. Give your answer as a percent, leave your answer as a fraction. Okay, I'll be very specific. 14. A die is tossed once. If the die is assumed to be fair, so all the sides are equal, it's just as likely for all of them to happen. Which event is more likely? The number showing is less than 3, so let's think about our options. We have a 1, a 2, a 3, a 4, a 5, and a 6 on a dice. So there's a total of 6 options. If it's less than 3, that means it has to be a 2 or a 1, so 2 possibilities, which is a 1 out of 3 chance, but it's 2 out of 6. Or the number showing is odd. So how many odd numbers are there? There's a 1, there's a 3, there's a 5. So that's 3 out of 6. So you could simplify that down to 1/2. But when you're comparing these, it's easier to look at the 2 out of 6 and the 3 out of 6. Because sometimes when you compare 1/3 and 1/2, you've got different denominators. It's harder to compare if they have the same denominator. So no need to simplify here. They're much easier to compare. Obviously, 3/6 is bigger than 2/6. So to answer the question, which event is more likely? It's this one, which is your odd number. That is part A. Part B, if a 4 shows on the die, what's the relative frequency that a 2 showed? So they're not saying there's another roll. There's just once. You tossed it once. There's a 4. They're already telling you it's a 4. What's the chances that you got a 2? So if you got a 4, what's the chance you got a 2? It's 0. $15. So a 14-foot long metal rod is cut into 2 pieces, and they're in a ratio of 7 to 3. So if this was a 10-foot long pole and you had a ratio of 7 to 3, you'd have 7 feet by 3 feet. Okay, but it's a 14-foot metal rod, and it's cut in the same ratio, so how long is each piece? So we've cut it into 2 parts, 7 parts plus 3 parts, total of 10 parts. 7 of them is on one piece, 3 of them is on another piece. We don't know how long those parts are, though. They're not exactly a foot. If they were exactly a foot, each part, then you'd have 10. But we don't. We have 14. So we have to figure out, we took 14, we cut it into a ratio of 7 to 3, a total of 10 parts. How much is each part worth? And then what are the actual pieces? How long are they? So we're going to divide by 10 here. So 14 over 10, you can simplify down to 7 over 5 as a fraction. That's actually a nice decimal, so if you wanted to, you could just call it 1.4. And so your 2 pieces are represented by 7p and 3p. So you can do 7 times 1.4, and you can do 3 times 1.4, and that will give you your 2 pieces. So times 7, it's going to give me 9.8, and times 3, it's going to give me 4.2. And always double check yourself. This whole metal rod was supposed to be 14 feet long, so if you're telling me that it's 9.8 and 4.2, they better add up to 14. And when you double check that and you add those up, they sure do add up to 14. And they're in a ratio, equal ratio of 7 to 3. Okay, last question. Review. Write an equation of a line that passes through the points 1, -8, and 1, 1. So if you notice between the two, the x value has not changed. So if there's a line connecting them and the x value has not changed, that means the x value is never going to change. If you want a quick sketch a graph and think about what this is going to look like, 1, -8's down here. 1, 1 is up here. So if there's a line passing through those, it's a vertical line. It hits the x-axis. You go up here. The x value is the same. It's not moving left to right. You go down here. The x value is the same. So the only thing changing is the y. X is always equal to 1. That's the equation.